So let's continue adding more to our multiple linear regression. Go back to our source, and now our model is going to be attendance is modeled by the home team, the visiting team, and the day of the week. And this might make sense. Maybe people go to more games on weekends and Friday nights as opposed to Monday through Thursday nights. But let's put it in the model and see how it goes. So we'll run this command, making a new attendance model. Look at the new summary of the attendance model. It's in our console. Let's take a look. Okay, start with the F statistic. It's got a very low p-value. In other words, the model is good. The adjusted R-squared went up pretty significantly. When we had just the model of home team and visiting team without day of the week, our adjusted R-squared was 0.4659, and now it's leaped up to 0.5349. And what this means is this is a better model for attendance. Again, residuals look fairly normal. That's good. The intercept represents now Anaheim as a home team, Anaheim as a visiting team, and now we can scroll down and see which day of the week is in this reference category intercept. It turns out it's Friday. Friday, and Anaheim being the home team and Anaheim being the away team, are put together in this intercept, and from there we have estimate adjustments for the home categorical variable, the visiting categorical variable, and the day of the week categorical variable. So now our new model includes home team, visiting team, and day of the week, and it turns out it's a better explanation for attendance. The model is better than our previous model, and that's done with adjusted R-squared as opposed to R-squared. R-squared went up as well, but we know it will always go up when we add new things to the model. So that's adding day of the week. Let's continue adding things to our model. Now our model will be attendance is modeled by the home team, the visiting team, the day of the week, and then by whether the game was a day game or a night game. This variable here is a categorical variable which just says day or night. And let's see if that improves our model. We'll run that. Hit run. It started here in our console. Hit the second run to get the second part. The attendance model is now complete with the new model, including the day-night categorical variable. Now let's look at the summary of the new model. The F statistic, still very low, meaning the model is statistically significant given our data set. And the adjusted R-squared went from 5349 to 5351, a very slight improvement in the model. Not much at all, really. The day-night variable went from day now is in the reference category. Day-night N for night decreases attendance about 473 people from the estimate that's our intercept. Now remember what this represents. This number represents Anaheim is a home team, Anaheim is a away team, Friday as day of the week, and day games as opposed to night games. So it's all put in this estimate, and then we have all the other categorical variables changing from there. Let's continue, and let's just finish up our code here for different models. Now we're going to create a new variable in our data frame. That's what this assignment does. We've seen this before, But now we're going to take RetroSheet home score and RetroSheet visitor score, add them together to get a total score of the game. So the home team scoring, the visiting team scoring, to get at the total score of the whole game. And the theory here might be that there might be an impact in the run scoring environment on attendance. Maybe fans like more runs. Maybe fans like great pitching matchups and less runs. We'll just try it and put it in the model and see what happens. Now when we run this command, we're adding a new variable to our data frame RetroSheet. So this should go up here. This number 12 should go to 13 as we add a new field in the data frame. Let's hit run. Yep, the data frame went up by one field. Let's run our attendance model assignment with our LM function. We showed that it worked down here. It worked, both those commands are in the console. Now let's look at the attendance model, see how things shifted. P-value is still very small. The model is significant. It does work, explaining attendance. And again, a very, very slight increase in our adjusted R-squared. Before we added the total score variable, our adjusted R-squared was 0.5351. Now adding score, it goes up a little bit more. When we look at total score is a continuous variable. It's not a categorical variable, but we can see that the total score, whatever the total runs of the game is multiplied by 32 to impact attendance. So it has a positive impact on attendance. Total score does. So the model shows us that fans slightly prefer run scoring environments that are a little bit higher on average given the data. Now let's continue on adding total home runs. Maybe there's a separate impact of the total runs scored in a game versus the total number of home runs scored in a game. So let's run that. First, creating a new variable in our data frame called total underscore home run. We should see this change here to 14. Well, I highlighted that incorrectly. We should see that change to 14. It does. Let's run the LM function again with total home run added. And we can see that, again, p-value, meaning the model is significant. Adjusted R-square went up slightly again, but a little bit more this time with total home runs than with just total score. So now we add the continuous components here, and only total home runs is significant. And so as total home runs increase at games, you impact attendance. So as home runs go up, so does attendance. But what's happened is now total score is virtually zero. Home runs has swamped out the effect of total score. If we scroll back to the other model, it's right here, total score was significant. It had a significant difference relative to the intercept, the reference category. It actually changed, it was different than the reference category, and now it's not. Total score is not significantly different than the reference category, probably because total score and total home runs do the same thing. They look at run scoring environment, and now home runs has a bigger impact than total score. So maybe fans like home runs, and they like teams that hit lots of home runs, and they go to those games more and increase attendance. Let's continue on with our model. We put a comment in here that the total score effect went away. Now we had that double header indicator. Remember, we added double headers at the very top of this R script. Now let's put it in the model, the fact that there's double headers there. Run the model and look at the summary of the model. The model is still statistically significant. Adjusted R-square went up to 0.5454. And doubleheaders is significant. Doubleheaders do impact a change on attendance, but it goes down. It decreases attendance by about 8,000. I'm not sure exactly the explanation. Maybe people can speculate why this happened in the attendance model in the discussion forums, but that's what we're doing. We're modeling attendance, and when we model attendance this way, when we say attendance is impacted by the home team, the visiting team, the day of the week, game being played either in the day or the evening, the total score, the total home runs and doubleheader, attendance is modeled well with all these variables. Now, total score may not be important, but it's still included in the model. All the data is included in the model for attendance. So that's an example, looking at baseball data, of multiple linear regression in R.